Eighth problem is find the smallest 4-digit number. Which is a perfect square. Now find the least number which is a perfect 4-digit least number which is a perfect square. So first of all we see what is the least 4-digit number. So least, or I will say the smallest 4-digit number. What I will say? Solution. Smallest 4-digit number. Yes, it is 1000. Now my perfect square number, either this 1000 will be a perfect square number or I have to add some number to this 1000 to make it a perfect square number. So we use that long division method and find the square root. I will make pair. 3 3 the 9. 1 is remaining. I will add 3. 3 plus 3 is 6. Then these two zeros I will take down. Now 6 1 the I will put here 1. 1 into 1 is 1. And 6 is 6. This one is added. 10 minus 1 9. 9 minus 6 3 13. 1000 is not a perfect square number. What we should add to make it perfect square? So again the procedure, what we say that remainder is 39 and this 31 square is going to be smaller than 1000. Square is less than 1000. So what we say? See what will be the square of next number. So we find 32 square. 32 square is 32 multiplied by 32. 2 to the 4, 2 to the 6, 3 to the 6, 3 to the 9, 4, 2, 10. 102. 32 square is 1024. Now this 1024 is greater than 1000 as well as is a perfect square number. So this 1024 is greater than 1000 and this 1024 minus 1000 will give me 20. Find the least 4-digit number. So therefore I don't have to find what number to be added. I have to find the smallest 4-digit number which is a perfect square. So better we rub this thing, no need of writing this. We will say that the 1024 is the smallest four-digit perfect square number. Find the smallest four-digit number which is perfect square. So understood the concept? We first taken the smallest four-digit number, and as it is not a perfect square number, we have find out what will be the perfect square number next to 31, which is 32 square 102. So 1024 is the least perfect square number, which is a 4-digit. We cannot have any other 4-digit number, least 4-digit number which is perfect square. Ninth question. Find the greatest number of 6-digit which is perfect square. Now first of all we see what is the greatest 6-digit number. Greatest solution is equals to 9 9 9 9 9 9. This is greatest digit number. Now either this number is going to be a perfect square number, or there will be a number smaller than this number which is be the perfect square number. So that will be greatest 6-digit perfect square. So again, long division method. By using long division method, we find square root. Nine nines are 81. 8 1. This 9 I will add. 9 plus 9 18. Now then I bring these two nines down, and if I put say 9 189 into 9, let us see what we get. 189 into 9. So 9 9 is 81, 9 8 is 72, 72 plus 8 is 80, 9 is 9, 9 plus 8 17. So 1701. 1701 is smaller than this 1899. So I will write 9 here and 9 in the question, and I will get 1701. Subtract 9 minus 1, 8. This is 9. This is 1. I add this 9. 9 9 18. 9 1. Then I bring these two 9s down. The next number which I write, say for example, I will write 198 multiplied by 9. Let us try what we get. 9 9 is 81, 9 8 is 72, this is 80, 9 9 is 81 plus 8, 89, and 9 is 9 plus 8 is 70. Again, it is smaller than this 9899. So I will write 9 and 9 here. So the number I will get is 17901. I subtract. So 9 minus 1 is 8, 9, 9, 1. I add 9, 9 9 18, 9, 9 1. So 1998, this what I am getting as a remainder. So if I subtract this 1998 from the given number, I will get a perfect square number. So what we do, remainder is 1998. So to get a perfect square, we subtract 1998 from 999999. So 999999 minus 1998 will give me 9 minus 8 is 1 0 0 8 4 digits, then 2 more digits, so 9 and 9. So this 998001 is a perfect square number. So therefore, greatest number of 6 digits greatest number of 6 digits which is a perfect is 998001. Then the problem, in a right triangle ABC, Angle B is given 90 degree, and the first problem is if AB is equal to 14, BC is equal to 48 centimeter, find it. Now, as the triangle is right angle triangle, so triangle is something like this. This is point B. I will take this as C and this as A. Now AB is given 14, BC is given 48. I have to find AC. In the previous standard, we have learned the Pythagoras theorem. So that Pythagoras theorem we will apply to find the value of AC here. What we will say that using Pythagoras theorem, AC square. Now square of diagonal. So here in this case, this is 90 degree. These are the sides turning 90 degree. So diagonal is going to be AC. AC square will be equal to AB square plus BC square. Now value of AB is 14. This is 14 square plus value of BC is 48. So 48 square. Now square of 14, 196, and square of 48. So on rough sheet, I will do 48 into 48. 8 is a 64 and 8 for the 32. 32 plus 6 is 38. 4 8 is a 32. 4 for the 16. 16 plus 3 19. 4 10 13 2304. So 196 plus 2304, and the answer is 6 plus 4 10, 9 plus 1 10, 3 plus 1 4 and 1 carry, so it is 5, and this is 2. So what we got? AC square we have got as 2500. Therefore AC is going to be square root of 2500. Now we can solve this by long division method, or directly you can see that 5 5 is 25. So if I take the square of 50, I will get 2500. So the value of AC is 50. Now they have given units in centimeter. So I will say that AC is equal to 50 centimeter. One more problem of the same kind, in the same problem. The second problem is I have AC is equal to 37 centimeter, BC is equal to 35 centimeter, and I have to find AC. So again I will make one right angle triangle. My point B is going to be 90 degree. This is A, B, and I can take this as C. Again AC, They are given AC which is 37, BC which is 35. So what we say that using, or I will say that by Pythagoras theorem, I will say that AC square is equals to AB square plus BC square. Now AC square is equals to, so AC, value of AC I have 37, so 37 square is equals to value of AB I don't have, so AB square plus AC is 35 square. So therefore this AB square, we will say that it is 37 square minus 35. Now square of 37, so again on one rough sheet I will find 37 into 37, 7 7 are 49, 4, 7 3 are 21, 21 plus 4 is 25, 3 7 are 21, 2 3 3 are 9, 9 plus 2 11, 9 6 3 1, 1 3 6 9. So this 37 square, it is 1369 minus, now this 35 square, so 3 into 4 is 12, I will multiply by 100 plus 25, so 12, 25 is the answer. Now 9 minus 5 is 4, 6 minus 2 is 2, 3 minus 6 minus 2, sorry, 6 minus 2 is 4, 3 minus 2 is 1, and 1 minus 1 is 0. So this AB square is 144. Therefore, this AB will be square root of 144, which is 12. So my final answer will be, therefore AB is equal to 12 centimeters. Eleventh problem. A gardener has 1,400 plants. He wants to plant these in such a way that number of rows and number of rows and number of columns remains same. Find the minimum number of plants he needs more for this. Number of plants he needs more. Now when word problem, here first we have to understand the problem clearly. Word problems, if we understand what they are asking for, then it is very simple. Now here the problem is gardener has 1400 plants and he wants to plant them in such a way that number of rows and number of columns remain same. For example, if we take that he is planting them in 3 rows and 3 columns, so how many trees he can plant? The answer will be, if I take 3 rows and 3 columns, this horizontal is row and this vertical is column. So if I am taking 3 row and 3 columns, total 9 trees I can plant. Similarly, if we plant them in 4 rows and 4 columns, then the number of trees that we can plant is 4 4 the 16. So the number of rows and columns, if they remain same, then the number of plants that we can plant is going to be a perfect square number. Now total number of trees which we have is 1400. So we will find a perfect square number which is more than this 1400. More than means there are many numbers which are more than 1400 in perfect square, but I should add minimum number to this 1400 to make them a perfect square number. So these kind of problems we have solved, that what number we should add to make the number a perfect square. So our proceeding, we use long division method to find the square root of this 1400. Now with 3 I will start, because 4 4 the 16, so 3 3 the 9. I get remainder as 5. I will carry these two zeros down. This 3 plus 3 is 6. Now if I take 7, 7 6 the 42. If I take 8, 8 6 the 48. So you can multiply on rough and see if 8 we can apply, but by this calculation, that 7 6 are 42 and 7 7 are 49, I understood that 8 will not give me answer less than 500. So I have taken 7. Now 7 7 are 49, 7 6 are 42, plus 4 is 46. Now I subtract. 10 minus 9 is 1, 9 minus 6 is 3, and 4 minus 4 0. The 7 when I add 1474. So this 1400 is not a perfect square number. If I subtract 31, I will get a perfect square number, or there must be some number which I should add. So definitely this 37 square which I got is less than 1400. Now let us see what we get. 38 square. So 38 square on rough, just multiply 38 by 38. 8 8 the 64. 8 3 the 24. 24 plus 6 is 30. 3 8 the 24 2, 3 is a 9, 9 plus 2, 11, so this is 4, 4, 4 and 1. Square of 38 is 1444. I already have 1400 plants in the garden. Then to make it 1444, how many extra trees I require? It is just 44 trees which I am getting from here. So what I will say, now 1444 minus 1400, it will give me 44. So 44 more plants gardeners need so that he can plant them in equal number of rows and columns. 12th problem. There are 1000 children in a school. For a PT, for a PT drill, they have to stand in such a way that the number of rows equal to number of columns. How many children would be left out in this arrangement? Now this problem is somewhat same as the previous one, that for a PT drill we want children to arrange in such a way that number of rows and number of columns should be equal. So when number of rows and number of columns will be equal, then it will give me a perfect square number. So my solution will begin to find the square root of this 1000. So we will first find square root of 1000. Now 3 3s are 9, 100. I will add this 3, 6. Then if I take 2, it will be more, so I will take 1, 61. And then 10 minus 1, 9, 9 minus 6, 3, 39. Now here I cannot solve more students because there are only 1000 students. So either I can arrange them in a perfect square, or I have to remove some students from this 1000 students to make a perfect square. Now here remainder is 39. So this 31 square which I am getting is less than 1000. That means I can make 31 rows and 31 columns to make a perfect square. Now how many children are left? 39 children are left. So what I can say that this, if I subtract this 39 from this 1000, I will get a perfect square number. So 1000 minus this 39, which is 1, 6 and 9, 961, and this 961 is 31 square. So the problem, how many children would be left out of this arrangement? So number 39. So I will say that 39 children would be left out. In this arrangement. So problem is simple. Either I have to add some number or I have to subtract some number to make a perfect square number. When I have to subtract, then in that case the given remainder is the required answer. And when we have to add number, then in that case we have to find out square of next number, like in this case 31. So we find out 32 square, and from that we subtract 1000 and see how many more numbers I need. Now 13th problem. Amit walks 16 meters south from his house and turn east to walk 63 meters to reach his friend's house. While returning, he walks diagonally from his friend's house to reach back to his house. What distance did he walk while returning? Amit walked 16 meters south from his house and turned east to walk 63 meters to reach his friend's house. While returning, he walked diagonally from his friend's house to reach back to his house. What distance did he walk while returning? Now, solution. Generally, in geography, we show direction like this, which is north, east, south, and west. So here, Amit walked 16 meters south. So we can use this notation, and from here, suppose this is the house of Amit, and from he start walking, and 16 meter he walked south. Then he turned to east, and in east, then he walked about 63 kilometers, 63 meters, 63 meters. So very suppose he is so I say that he suppose A is the Amit's house. So he walked 16 meters to south and reached a point say B. Then he turned to east and walked 63 meters. Now this angle is 90 degrees, as north and east they are perpendicular to each other. And he reached his friend's house, which is C. Now while returning, he has moved diagonally. So while returning, he used this path from C to A. And this I have to find out. What is the value of this AC? From this diagram, we see that here we can apply the Pythagoras theorem, as this is a right angle triangle, this angle be 90 degrees. So what we say? We say that by Pythagoras theorem, AC square is equals to AB square plus BC square. Now the value of AB is 16, so I will say 16 square plus 63 square. 16 square is 256 and 63 square, so here we do a small rough work. 63 into 63, 3 3 are 9, 3 6 are 18, 6 3 are 18 and 6 6 are 36 plus 1 37, so 9 6 9 3. The answer what I got is 3969, and the result is 9 plus 6 15, 6 plus 6 12, 1, 9 plus 3 12, and this 3 plus 1 4. 4225 AC square is 4225. So therefore the square root of this 4225 will give me the value of AC. Now as the n two digits are 25, I have to see whether this 42 is multiple of the complementary number. It is the multiple of 6 and 7. 6 7 is the 42. So what answer I will say? This is 65. The value of AC is 65. So my answer is going to be, what distance did he walk while returning? So Amit walked 65 meters. What I will say that Amit walked 65 meters while returning from his friend's house. The last question, 14th one. A ladder (6 meters) long leaned against a wall. the ladder reaches the wall to a height of 4.8 meters. Find the distance between wall and foot of ladder. A ladder 6 meters long leaned against the wall. The ladder reaches the wall to a height of 4.8 meters. Find the distance between wall and the foot of the ladder. Now, there is a wall. The wall is going to be a vertical one like this. So this is a wall. Straight wall. This is a wall. I name it, suppose AB. And this is the ground. On this ground there is a ladder which is leaned like this, and the length of this ladder is given 6 meters, and the ladder reaches the wall to a height, the height is given 4.8 meters. I have to find the distance between this wall, that is AB, and the foot of ladder. So this ladder, this here I am getting the foot of ladder, so I name it as C, and what I have to find? I have to find BC. So here height of ladder, so height of wall at which the ladder is reaching is given. So the things given is AB is equal to 4.8 meter, AC is 6 meter, and angle B is 90 degrees. So this angle B is 90. Again we can apply the Pythagoras theorem. So what I will say, that by Pythagoras theorem, AB square plus BC square is equal to AC square. Now AB square, the value of AB is 4.8 square plus I say BC square is equal to 6 square. So this BC square is 6 square minus 4.8 square, which is 36 minus, now 4.8 into 4.8, so 4.8, 4.8, 8 8 the 64, 6, 8 4 the 32, 32 plus 6 is 38, 4 8 the 32, 3, 4 4 the 16, 16 plus 3, 19, 4, 10, 3 and 2, 3, 0, 4. Now 4.8 after decimal 1 digit, and in this 4.8 after decimal 1 digit. So in my answer there should be 2 digit after decimal. So I say that 23.04. So 36 minus 23.04. This will be equals to 10 minus 4 is 6, 9 minus 0 is 9. Now 5 minus 3 is 2, and then this 3 minus 2 is 1. 12.96 is my BC square, and therefore the value of BC will be equal to square root of 12.96. So this 12.96 square root, for square root, what we can use? We can use the long division method. So here 12 point, or what we do, here we take that 12.96, 3 3s are 9, I got 3, I will shift decimal on up, 396. Now this 3 plus 3 is 6, and this 6 is there, so 6 I will take, 6 is 36, 3, 6 is 36 plus 3 is 39, I subtract, I will get 0, so 12.96 square root I am getting as 3.6. 3.6. So value of BC is 3.6. So the answer which I will say is that the distance between the wall and the foot of ladder, so therefore distance between the wall and foot of ladder is equal to 3.6 meters. This is the final answer.